Stage is yours.
Thank you. So Thomas, are you still here or you escaped the room? So Thomas escaped the room, but talking about the persuasion, he's coming from UK, right? And he doesn't know the fourth approach what we have in Nordics and Baltics. We have, as you know, we have very innovative solution. So special houses or booths where the persuasion, happening massively. So we call them saunas. You just grab enough beer with, and a kind of a persuasion works well. Yeah, but it's a bit risky. Okay, so today we kind of have slightly different topic about the performance testing. But before talking about this, very short introduction about who we are, right? So my name is Jurijs, and I'm leading quality engineering groups in Accenture Baltics and Nordics as well. So that's my second hat. And in testing, I'm 20 plus years. I stopped counting, otherwise I understand how old I am. And today we wanted to touch more non-functional topics related to this. Yeah, so we'll be speaking about this. My friend Leo.
Hello, my name is Leo. I'm also in testing for more than 15 years. And to know me better a bit, I have to bring my very small tradition. I will announce a good news. Today is Friday. This is what I do every Friday on every stand-up, and people are aware of that ahead we have a weekend. And yeah. So in performance testing, I am for last over like 6-7 years and landed up in this very cool niche of testing. And now I'm leading the practice group in our company.
Yeah, and we decided to come both of us, right? Because yesterday you saw there are some changes in the program, yeah, and we wanted to deliver reliable presentation where there are, something can happen always. So, and that's why we selected such active solution. Okay, but today we'll speak about three important areas. So first of all, cloud, yeah, and the performance testing. I'm pretty sure that everybody is familiar with the key concepts of the cloud, that there is kind of a migration, that Google Cloud, Amazon, Azure, yeah, so that's cloud. But what's specific for us, for quality engineers in this, yeah, and how to address this change, yeah, and this I will cover from our side, from my side. Then Leo, or sometimes I call him Leonids, when he is kind of fighting with developer team, then he will deep dive more in the technical perspective of the performance testing, how we are doing this, and improving the systems. And at the end, I will mention how we can actually deliver this and how we are doing this. Yeah, because it's pretty obvious that so many different companies, so many different organizations, technologies, sizes, and so on, and there will be different approaches how to do this. So let's go start it. Cloud is everywhere. Sometimes we even don't feel that we are in the cloud, but if you open your mobile phones, then you will see actually just ordinary applications, and you will not even consider that these applications are working on the cloud. Yeah. Only a few examples about the applications in the cloud. Then it's Spotify, Netflix, Twitter, and many others. And just take check for the Netflix because everything what we will discuss today, you can recall it back and then try to map it to the Netflix as a platform. So cloud is not a future, it's kind of a today already. We see quite many clients moved already to cloud solutions, and another part is still going to it. Cloud, for example, Amazon Web Services, it's a large number of small pieces, services they do provide. In Amazon, they have more than 200 small services related to databases, serverless applications, access rights, storage, and so on and so on. It's kind of a huge list of the services available for the technical architects to build their systems. And the complexity for us as a quality engineers lies in this. So, because in one case, there will be one set of the services, and another case, there will be completely different set of the services. The services can be and will be integrated in between. And then moving to the next complexity level, I have mentioned only Amazon Web Services. So there is also Azure, Google Cloud, and they have their own set of the services. And if we speak about the bigger platforms and clients, what we have on the market, then they are building solutions using multiple clouds. They're adding also some on-premise environments there and integrate it together, And then you can understand that you don't understand anything there anymore. So cloud solutions are complex, built from the small pieces. And at Accenture, we did several surveys because we are in the close touch with top 200 biggest companies in the world, and we kind of wanted to understand where they are in their journeys to the cloud. And we learned that majority has started already migration to the cloud, but the rest are kind of still planning this. At the same time, they face a number of different challenges, and we will mention this on our next slides. So here, as you see that, for example, we can say, yes, so everybody is there, so 41% has already, almost there. So they have almost completed their migration to cloud. Then 32%, they kind of, we are done, all good. But then the rest, there's 3 groups. So yes, we are still thinking about this. Yes, we have a vision that we need to move to cloud. Or they started some internal processes how to migrate. So if we kind of take these left 3 groups together, so we see that 1/3 hasn't started any kind of the migrations yet, but I'm pretty sure that they will do it. And the rest 2 groups, so today they say that yes, we have kind of done or almost done, but I'm pretty sure that they will get back to this. They will review their strategy in this, and they will require changes in their infrastructure and the technical platform. Cloud is not a panacea. It doesn't mean that you enter the cloud and everything is available and kind of there are no limits, so you can easily get increased capacity of the environment and so on and so on. From my perspective, there will be even more complications, and from the quality engineering perspective, we see if there are complications, these are not tested, we should expect some outages, defects, and so on, right? And I didn't want, and actually, I think I am also limited to kind of share something, but still it's very easily can be found in the Google, just Google this keywords, so what were the top outages during the previous year, this year, and Google will tell you kind of what were the problems. And by the way, one was my snapshot, what I put it, because I'm facing this issue regularly. It's a global payment provider. So it happens. So what are the key challenges? And here I didn't hear actually during the 2 days quite many times repeating ChatGPT, so kind of I will tell it several times, so ChatGPT. I wanted to try out, and see what ChatGPT will tell me about the challenges of the cloud migrations. This list, what I got was quite a cache. Yeah, so validated this, of course, yeah, but as per ChatGPT, you see there's challenges in the cloud migration, and I have highlighted the challenges that are directly related to quality engineering and also the performance testing. Yeah, so complexity of the applications, performance and scalability, cost management, overall testing and quality assurance, how to ensure that not only from the non-functional perspective everything is working, but also from the functional perspective, and monitoring and management. Yeah, so quite many impact and challenges what we see from our side. Then how to solve this? It means that, okay, infrastructure is changing, architecture is changing, we need to address it properly. Yeah, and as usually it's not black and white, so it's not that you are kind of on-premise or you are in the cloud. So there are different levels of maturation. Sorry for small text here, but I'm pretty sure that your modern mobile phones can handle this zooming, and afterwards all the materials will be shared anyway. Yeah, but the idea here is to show that, when we are moving to the mature cloud solutions, then we are also rapidly changing our performance testing approach. Yeah, so previously there was a box or several boxes where we wanted to understand what is the maximum that these boxes can handle. Nowadays we don't have these limitations, right? So we are discussing about the scaling, about the disaster recovery in the cloud, reliable solutions, yeah, and how to handle this, meaning how to test this. So that's all from introduction side. Now you are kind of do understand that in performance testing is a necessary part of any cloud migration, and giving the device to
Thank
Leo.
you. Okay, we had like a spaceship view on the topic. Now I will provide some helicopter view in more details on performance testing in the cloud. And then we go down to the ground to some very small performance testing type. But before starting to test something in the new platform like a cloud, we need to understand what actually is the difference between our traditional testing in on-premise. So we have listed a lot of keywords on this slide, and the main point is that at any of these big topics, like in scope, you have a different scope for the cloud. Cloud is something like a rocket machine comparing to bicycle when you have on a physical server on a premise. Yeah, it has much more capabilities, much more flexibility, and all this much more needs to be tested. Yeah, test environment is a very huge topic. It's all about test environment. You are not bound to some limited laboratory with hardware services. You can choose any cloud provider. They have multiple locations in the world. And this also needs to be tested. Test tools, we have now on-premise traditional test tools, which can be used in cloud, and we have cloud test tools, which can be used in both on-premise and on the cloud. And it's better to test cloud with the cloud tools, because naturally they will live together. You can do it more effectively. And as well as the cloud is highly scalable, your test tools should be also be highly scalable to make sure your test tool is not the bottleneck, because you need to test a huge cloud. And how do you do this? It's not an easy task anymore. it's very hard to push it to the limit, because performance testing is about finding the limits and making sure we can do our job at the maximum possible effectiveness. Monitoring today in the morning, it was scored that like when you have 20 services for one small client, you move to cloud, you have microservices, you test each separately, but you don't understand the whole picture. Here is where monitoring, this keyword monitoring transfers into the word observability. It's like you need to know your system, not only in your, again, the topic was called testing in the production. Yeah, this observability is basically, it's attempt to test in the production. By like looking at the production, you can find a lot of bugs. You can imagine like no testing needed. If you have a good tools, they call like application monitoring tools, and you have access to production monitoring, you can find bugs right away by checking the logs, graphs, and so on. The only thing you need is a good helicopter view and microscope view on everything. So it's super big, super important topic. I think half of my work time I spent on observing the results, analyzing, and monitoring speeds me up. Without monitoring, you will be slow as a turtle. Yeah. Methodology is also affected. In cloud, we are more agile. We are not geo-restricted like people from around the world, especially in like work from home mode, can connect to the cloud. The only thing you need is good internet connectivity, yeah, and you can work with multiple teams spread around the world. The requirements also now different. Everyone needs to be aware of cloud, needs to know the cloud, how to work with it. It's a different mindset. It's really new knowledge that every person should get. So, that was helicopter view. We're going slowly to the point of our topic. From this slide, we can see that there is nothing new. The old stuff is there. We need to test everything as usual, but all these points are intensified, and in the cloud we have a focus more on scalability, on doing what your business, like on the business goals, what we expect from cloud. So we expect that business can grow rapidly, that everything can be deployed faster, that we have zero outages, and we pay less money. And from all this list of things, yeah, we have two very big topics, like which previously it was not big focus on performance testing. Like if you remember, previously like performance testing was done somewhere at the very end stages just because we need it. But now business really sees that performance testing is a very important part, and we have two keywords here: performance testing and disaster recovery is the one new thing we should know about. How to do this? Basically, there is all the traditional process should be in place, but in each category, yeah, we have some slightly different approach. We need to think about the cloud is different, cloud is more flexible, there is more things, and we need to be more careful with each stage. For example, first of all, we need to capture some requirements. It's very hard to capture requirements about the new system, what it should do. We should define the goals, and we should remember that this performance testing goals, they transfer to performance engineering goals. We need to fine-tune this system, not just to check the system can do what it's expected to do. We need to ensure much more different goals about resilience and reliability. This is what we will talk about today, more focused. So this slide shows a lot of small topics, what you need to think about when you start performance testing, when you want to make a resilient, reliable system that can scale out and having like the best value for the money. And cloud performance testing, it's about fine-tuning and about getting the best service, the most robust, resilient application for the money you pay. It's very easy to overuse the budget for bringing up some resources which are not used. Without monitoring, it is hard to understand what is going on, what you are paying money for. Cloud services, they have special kind of dashboard, like with the how much money you pay and for what. It's like 100 points in the bill. And it's very important and very useful service actually for every customer who uses cloud. And they can track what is consumption. So resiliency is such a big term, and it consists basically of two parts. Like before things go bad, like this is availability. We want to ensure that services scale and cope with the increasing load, with sudden challenges, with sudden peaks, and that service survives under pressure, under maybe hacker attacks, under some natural disasters. And disaster recovery, it's completely different but very important thing. It's a basically new thing that comes in because the cloud enables you to do this. Disaster recovery is about the time you spend to recover after the problem has happened. So in the first thing, we want to prevent problems, but problems happen due to anything. Like in cloud is very complex and anything can go wrong. And disaster recovery is about the plan and your readiness to recover from some very big issues. And the faster it is, the less money company will lose. And reputational risks are also bound to like your resiliency. Typically, everybody knows that cloud is so cool. It provides you all this scalability, flexibility. You need more compute power, you just pay more, but it's not enough. Cloud providers, they have responsibility on the platform, on their hardware. They have these different regions. You can deploy services across the world. Like there is earthquake in one country, your services are immediately available in another geographical region. But this is about the platform. But for the customer, for the business, it is very important. So cloud removes this responsibility from the people who use it. It's their responsibility, it's a basement, yeah, and on top of this you need to build your house, and it's about customer to apply the best practices and to build architecture that fits your needs. And there is endless possibilities to combine all these 200 different services together, and respectively you need to test it, and it's all about like we are not testing the cloud itself, but we are testing architectural solutions in first place. If you want to make a system that will work reliably, you need first to build a good architecture, then build all the services, get from this helicopter view to in details, test each server separately, and you need to know that this system works as a whole. And yeah,
if I want to add, Leo, I just wanted to add, because can you just move back? Also, these cloud providers, yes, they say, yes, we are responsible for this infra and so on, but we don't guarantee this. Everything can happen, that's why you need to have not one site, you need to have 3, 4 different sites and so on. So please build your reliable architecture. So this is this upper part, So.
Yeah. And what is disaster prevention and recovery? Yeah, this is the thing that is your strategy, how you will recover from the problem. In cloud, you have a lot of different options. starting from traditional backup and restore, where it can take up to a week to restore your database, all the services. If you have like your server burned out, you need to put a physical server, take a backup, storage back, connect everything, boot up, and it should work. After a week, you will lose a lot of money. So the time is money here in this place. And different modes, this like pilot light, this is something what is in aviation is used, like the small engine which can start the big engine. But it needs quite a time, like some 5 minutes. Warm standby is another thing that you have a copy of the server, but it's not boot up, it's not up to scale, it's just running, and it takes a couple minutes to, if your main service is dead, this standby service will boot up very quickly, in a few minutes. And the most advanced thing is just having a copy of production, and the switchover can happen in seconds. Basically, this stuff is used in telecommunication, so they always have everything by double, like hardware, active. If you just remove one piece of hardware, second piece will immediately take into action. And this is most. So today, I will also speak about availability. Basically, availability, it's all about the metrics and the approach how you support these metrics to come through. It's a time spent on downtime, like time online divided by kind of time downtime. So ideally we want to have 100% availability. And how do we address the issues when we have spike in the loads, when we have some troubles? First off, the very, very basic thing you need to ensure that works properly when you are in cloud, when you want to build a scalable business. You need to ensure that if there is higher demand, you need to boot up, bring up additional resources, like they should start serving new higher load. There is like a vertical and dynamical scaling, horizontal scaling.
Let's go to the practical example so people will understand how it's managed.
I recommend to take the slides after and to read. There is a lot of things. So, scaling. Scaling is the ability of system to scale up and down. And both steps, up and down, is important. If your system is too big, but the load is too low, you waste the money. If your scale is low, but you have some higher demand, your system will break because it cannot serve the load, it will be slow. So here, all is about effectively spending the money on the resources. Because the cloud provides you all the resources, you just need to pay. But if you design your system not within the best practices, you will end up that people will talk about like cloud is nothing better than our traditional stuff. Because you pay so much, you can buy the hardware server, it will do the same stuff. But cloud is all about flexibility, about not wasting extra money if you are design your system in clever way.
Let's skip this.
This scaling. There is 4 modes.
Let's skip this.
From manual till very artificial intelligence driven. So how to do the auto-scaling test, or how to test the auto-scaling? First of all, we need to understand, it's all about fine-tuning the provided by the cloud tools. If you just go without testing and fine-tuning, you will end up that stuff will never work out of the box as you expect. It will work somehow with delays, and there is a big list of what to do and what not to do and what to be aware of. And let's see the real examples. First step, now I will be talking about like the stuff, the experience, what I got from practical testing. When we had got this migration to the cloud, we started to use virtual machines, then we switched to containers stuff, yeah, and we had a very long time for devoted for performance testing and fine-tuning. And even there, like, no one expected that it can take more than like a couple weeks. We took a month to do final fine-tuning. So in my practice, how to do a good performance testing for the scalable tasks? First of all, we need to measure capacity of one small thing, of one virtual machine. Yeah, and then with this auto-scaling features of the cloud, you can add more machines, depends on the load. But if you don't know what is your one small piece is capable of, you cannot even count how many maximum like number of these containers you need, how many containers is enough to start with, like how many containers you need during the low load, how many containers will be enough during peak load. Everything is ready to ramp up 300 small containers. You will be surprised if you will try to ramp up 300 small containers. The problem will be not in containers, but your IP addresses will be finished because like usually load balancer has some limit on 250. You can expect any different issues during testing. So it's a very interesting topic. So we do one test, we clarify where is our maximum for one service. From that we can start our dynamic testing. We can start the testing, the auto-scaling. And the idea of this testing is to ensure that system will scale out and down, exactly touching the same shape as your workload. Yeah, this picture is from real monitoring statistics. Yeah, and I draw the red line is like our ideal world would be that system will scale rapidly to the same shape what you need, and then there is no gap in like resources you pay for and unutilized resources. You will pay only for what you use, and this will be ideal cloud world. And this is what happens in reality. Your auto-scaling doesn't work properly. You just configured with some default settings, your load is going up, and you see that there is a huge delay between the need of auto-scale and in reality the auto-scaling happened. And after the peak has gone, like there is no workload, at the night your containers still are there, they don't downscale properly. So here we have two problems, slow reaction, slow scaling up, slow scaling down, and you completely mismatch the traffic profile you need to cover. This is another case when you configured auto-scaling but forgot about that you also need to downscale the services. Then you just waste your money constantly till someone notices. And if you don't have this observability thing, if you don't monitor your production, you will end up that in the end of month you will get a huge bill and people will ask why we have so much waste on the unutilized resources. So this example is a bit better. We have a good scaling up, but then we can realize, oh, our scaling down is going step by step, and it's so slow that we still have this big difference between money we spent and money we had to spend. And the next example will be, again, low efficiency, like still big gaps. Scaling works well, but it's slightly delayed. And in one place, there is one spike, sudden spike, it's not covered. So at this point, you will have some couple minutes service break or slowness. And here is a very important point. It's like you need to understand to which extent you need this resiliency to be. Is it okay, like for a couple minutes, that response time to the end clients will be slightly slower, or you don't want to have any slowness, you want stable performance during all the days, and this will cost 3 times much more money. Yeah, so this is about like how much money you can spend on these features. And this is an example of perfectly tuned auto-scaling. We have these steps because if we have these compute machines, you just boot up one machine, it adds you like a step of the new capacity you can cover. And yeah, this is all based on the real practice, and I have a lot of details. If you want to discuss me how to do this, it's only 1% of what we are actually doing and what can be
But don't
done.
go so far. Yeah, I already saw the light, this, hey, it's finished. Yeah, so finishing this, yeah. In any kind of the migration to cloud, we see that the performance testing needs to be there. All kind of the migrations. So performance testing need to be addressed properly. And there are a number of different options how to address, how to deliver, embed people into development teams, deliver this as end-to-end service, and that's another story. Yeah, thanks a lot. Yeah, I don't know if you have a time for questions.
Yes, we do have time for questions, so I'm glad to take a few.
Okay. Hello, I'm Ernest. Thank you for presentation. My first question is how many times you burn your budget on for the performance testing? Because it happens twice for me at this moment.
So the budget for performance testing?
Yeah, so we saw our Azure has a limit for the funds, for the burning the money on it. And let's say my performance test burned it twice to this.
Yes, very good question. I have the observability over production. I see production is like X money. Performance testing can eat up to like 50% of what costs product. We have the biggest environment. It's like in only my hands, like people of team of 3 people is burning like all this money. Plus the tools, they also in the cloud. And but there is an option how to save some money. If you have million of microservices, they based on the same template. So we tested this auto-scaling one time. We know what to expect. We know these limits. If we build similar service, it will be enough to test only one small instance, not going to the full-scale test. In production, it will be like 20 instances. We will run and test one instance, record this, what is the capacity. We know that we can multiply the load. And if needed, we can do a very, very short and not costly test for half an hour just to see that 30 service will work together. And that's the formula.
But anyway, testing budget in this case anyway will be much, much lower than the savings from the production. And you need to address this in a such way.
Very, very easy way how to save money. You go to production and see this service.
He has a lot of,
not utilized. It's having one request per week and you have like 3 instances running $100 a day. You go to the manager and say, we need to shut down this. And then you save a couple thousands.
Thank you.
I did the same thing last week. Just no one looks at the stats.
Thank you.
Shut down the product, right? So, any more questions?
Any more questions? No?
Yeah, there's one.
Okay, thank you. So I have also a bit dangerous question. How do you generate the load? Do you build solutions yourself, or you already use some predefined offers? Or let's say you want to test, do this performance test. You want to generate a really big load. You have like lots of different microservices and all. Like in practice, how do you do it? Do you have your own built-up solutions already, or you use something from the market?
So most popular 2 tools are Gmeter, which is free out of the box, and LoadRunner is the another thing. And the good thing that Gmeter is like a standard for the market, you buy some cloud tool, it accepts Gmeter test. So it's very easy to start with Gmeter because it's like you can just use it anywhere, don't need to care about licensing. But if you need to go to scale, you need to buy some cloud product that you can run a test from there and you can scale your test. And you have some this CI/CD there. You don't need to care about automating the perf tests. If you bought the cloud product, the automation will be included, and this reporting and all the stuff. So it's.
And I would add Neolot as well as rising in the popularity and capacity.
Neolot is popular.
Yep.
Yeah, it's similar. It's kind of combination with Gmeter plus Load Runner. They took best features in their new. Yeah.
So thank you, Jurijs and Leonids.
Sorry, it took a bit more time. Thank you.
Thank you.